Alright guys, this is just a video to go along with the review that I already went over with you guys in class. So again, this is just everything we did in my classroom, okay? And so another reminder guys, I know I already said it, and if you saw the other video, you've seen it in there as well. Equations you need to remember are the ones for magnitude, x squared plus y squared, okay? You need the dot product, u1 v1 plus u2 v2, excuse me. You need the rectangular to polar. Well, let me start with the other one. Polar to rectangular, which is r cosine theta and y is r sine theta. We're going to use these right now in a little bit. And the other ones are r is equal to square root of x squared plus y squared, and tangent theta equals y over x. Okay. So again, this was the problem that we did in class, and if y'all remember, this one we decided was a linear moving problem. So remember, this was for my parametric equation. My x equation is going to be v naught plus vx times t, and y is going to equal v naught, excuse me, I should say v naught in the y direction and v naught in the x, plus velocity y times t. Okay, so that's all the stuff we want to find. So I'm going to write it off here to the side: v naught x, v naught y, I'm sorry, this is x naught and y naught. My mistake, guys. I'm sorry. X naught and y naught. So still the initial positions, vx and vy. Okay, so here we're trying to find Bob's parametric equation. So if we read this, Bob is jogging in the park. He started at the origin, so he starts here at 0, 0. And he went to the point 15, 5. So 1, 2, 3, 4, 5. Over here, 15, 5. After 10 minutes. Excuse me, 10 seconds. And so, if I want to fill in this, his x position, where he started, over here at 0, 0. This is 15, 5 over here. His initial position is 0. So, this is 0. My velocity in the x is, remember, x final minus x initial divided by time. So, my final x is right here, 15. Minus his initial, and again just the x, 0 divided by 10, so it's 15 over 10. Now guys, if you want to go ahead and reduce this, if you know how to do this in a decimal form, that's okay. If you want to leave it in a fraction, that's fine as well. This does equal 1.5, so we'll leave it like that. Okay, this one was easy enough to figure out. His initial y is 0, so put it at 0. And his velocity final, remember, is going to be y final minus y initial over time. So here his final y is 5 minus 0 divided by 10. So 5 over 10, which is 0.5. And if I want to make my equations, these are hit right here. X is equal to x initial, which is 0, plus velocity x, 1.5 t. Which you can just write 1.5t. You don't have to write the 0. y is equal to 0 plus 0.5t, which equals 0.5t. Okay, so that's Bob's equations. Excuse me. Okay. Another jogger now, Annie, starts at negative 10, 5. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. She started right here at negative 10, positive 5. And she goes all the way to 20 and 0. So that's going to be somewhere up here. And 0. I should have made that in another color, guys. I'm sorry. But so if I want to do, again, this right here. Now this is for Annie. I'm going to write this off to the side. X initial, Y initial, Vx, Vy. So her initial position in the X right here is negative 10. Her initial position in the Y is positive 5. And velocity x, again, we're going to use the same equation. So her final x is 20 minus a negative 10 divided by the same amount of time because she took 10 seconds. So this becomes 30 over 10, which equals 3. And we're going to do the same for y. So this is final y is 0 minus, right here, a 5 over 10 I'm sorry, this is a 15. This should be up here somewhere. We'll pretend that's at 15. So change this, guys. These are 15s. I'm sorry. This is negative 15 over 10, which is negative 1.5. So her equations are going to be x equals negative 10 plus 3t. Y is equal to positive 15 minus 1.5t. Okay. Here they're asking if the joggers collide, and so we talked about this in class again, guys. This is just I need to have the same. They have to have the same time if they're going to be in the same x and y position. So all I'm going to do is choose this equation right here and this one right here and set them equal to each other. 1.5t equals negative 10 plus 3t. And we'll use NSOLVE to see when do they actually collide with each other. Okay, so I'm going to grab the calculator here. Well, my calculator's not working. That's okay, I can solve this by hand. These numbers are very simple enough. So this is going to be negative 1.5t equals negative 10. .67 seconds. And I want to do this again with the y's, so this is going to be now this y equation, 0.5t equals 15 minus 1.5t. So here t is going to equal 7.5. And we see that these are different times, so do they collide? No, they don't collide. Okay, because they're not the same times. Okay, so moving on. Find the rectangular coordinates of the points with the polar r and theta. So here they did tell us that these were polar, but remember this, when I see pi, this means that this is an angle, and angles I only have with polar. So if I want to turn these, that's going to be x equals r cosine theta. Y is going to equal r sine theta. Okay, so here is going to be 3 times the cosine of pi over 3. And this one is going to be 3 times the sine of pi over 3. Okay, and so if I had my unit circle, or you are going to look at your unit circle, I should say, and you go to pi over 3. Okay, so at pi over 3, my coordinates are 1/2 for the x and square root of 3 over 2 for the y, which we already know this is the cosine and this is the sine. So what I'm going to do here is replace it. This becomes 3 times the cosine, which is 1/2. 3 times the sine, which is square root of 3 over 2. And this is 3 over 2. This is 3 square root of 3 over 2. You can even like that, okay? I mean, if you want, you can go ahead and reduce this one to 1.5. You could do the same here, 1.5 times square root of 3. But you should be fine if you leave it in the fraction form, okay? And the same is going to be done for this one right here, for 210, but this is now in degrees. So x is equal to r cosine theta, which is 2 times cosine of 210. R sine of theta, which is 2 times sine of 210. And at 210 degrees, at 210, let me put this over here, your coordinate is negative square root of 3 over 2 and negative 1/2. So here it's going to be 2 times negative square root of 3 over 2, which is negative 2 square root of 3 over 2. These will cancel. You can just leave it negative square root of 3. That's fine. This is going to be 2 times 1/2, negative 1/2. So this is negative 2 over 2, negative 1. Okay, so that's how you would do this. And remember, guys, you need to write them as a pair. So negative square root of 3 and negative 1, something like that. Okay. Last one here. Okay. Y'all have been doing pretty good on these, so I'm going to go ahead and go through this real quickly. Remember, this is 3u plus v, so I want 3 times u, so 2 and negative 1, plus 5 and 3. Okay, there's no number in front, so I'll leave it like that. So first thing I want to do is go ahead and multiply, so this becomes 6 and negative 3, plus 5 and 3. So now that there's nothing in the front to multiply, guys, now I can x with x, y with y. So this is going to be 6 plus 3, excuse me, plus 5, and negative 3 plus 3. So this becomes 11 and 0. And if you want to do it in linear form, remember it's just 11i plus 0j, which if you have a 0, you don't have to write, so this is just same as 11i. Okay. Depending on how they're asking for it, usually if you start in component form, you're gonna give the number in the answer in component form. But if they ask for linear, you're prepared for that too. Okay, so don't forget to study those equations I told you about. Guys, last week we covered the graphing. So graphing the polar equation. So study that as well. It's on your review guide. So with that, guys. Just study and good luck, okay?